Okay, so I asked you to look at 49, 50, and 51. So the answer here is that you can move the vector, but you can't rotate it. That changes the direction. And you can't change the length. That changes the magnitude. But you can move it because that's what you do when you add things tip to tail. Like this. Tip to tail. Now for 50, what's the resultant? Well, what does it mean? I gave you an example the other day. It's the result. When you put two things together, it's the output. It's what you get. And 51, what if you add things in different order? Well, that's like 2 plus 3 versus 3 plus 2. You end up with the same result. Let's see, what else did I ask you to do? 69, 72, 74. So let's see. 69. So the largest you could get is if they were both in the same direction. 3 plus 4 is 7. If they're in opposite directions, then that'd be one's 4 and one's 3. You get 1. Subtract them. Let's see. What was the other stuff? 72, 74. Alright, so let's see. We've got a velocity 60 degrees north of east. So let's see. We're starting from east. East is this way. North of east is there. So about like this. And so you draw that vector on your paper. Coordinate system with positive x going east and positive y north. Which component is larger, the x or the y? So if your vector is like this, all right, which is larger? X, the x part, or the y part? Think about that. It's the y part. Y. All right, and next one, this one. So a car is going up a hill, so we choose that the positive x-axis is actually with that hill. And that means that the y is actually like this. And that makes life a little bit easier with the components. That's why we do that. So we also have a stone that gets dropped on the car. Which way is the stone going to fall? Straight down, right? So what would the components be of the stone? If it's falling straight down, it's like this. So it's going to have part of an x component that way. And then it's going to have part of a y component this way. Remember, because y is in this plane and x is in that plane. Okay, so that's those.